Hello, my name is Hasan Karahan. I am the CEO of Blackhan Software Limited, and I would like to talk about the GINI coefficient of proof-of-stake blockchains. Next page, please. Well, as you know, we have proof of work and proof of stake, and both of these are so-called civil protection mechanisms. And what is a civil protection mechanism? It's a way to establish a digital identity in a decentralized environment. Simple as that. And next page, please. Proof of work is a form of cryptographic proof in which one party, the prover, proves to the others, the verifiers, that a certain amount of a specific computational effort has been expended. So you work hard, and then the others, the verifiers, can subsequently confirm this expenditure with a minimal effort on their part. So this asymmetry is important. You need to work hard and long, but the verifiers, they can quickly verify it. Next, that's proof of work. Next, please. Well, here we have also the other civil protection mechanism. Most people, which is proof of work, and here validators are selected in proportion to the amount of holdings they stake in an associated cryptocurrency. And here I want to point out proof of work and proof of stake, they are not consensus mechanisms as usually stated wrongly. They are civil protection mechanisms to establish an identity. In proof of work, you spend electricity essentially to prove that you're somebody, and then proof of stake, you show that you have money, which allows you to essentially speak in a group of validators, people, machines, and speaking in this context of blockchains means you have the right to produce a block. Next, please. And here I also want to mention the GINI coefficient. And it seems like a complicated formula, but essentially what this GINI coefficient measures is the difference between the poor and rich people. So it measures the mutual difference between each participant, each validator, and normalizes it between 0% and 100%. So the GINI coefficient essentially, again, total difference divided by the maximum possible difference. Next, please. Next page, please. All right, what does that imply? So a GINI coefficient of 100% means that the king owns everything and nobody else owns anything. Winner takes all. Next page, please. A GINI coefficient of 0% essentially implies communism. There is no difference among the validator stakes. Everybody has the same stake. And because everybody has the same stake, there is no difference. And therefore, the total difference is 0. Therefore, we have 0%. Next. So the GINI coefficient in a proof of stake blockchain, the higher the GINI inequality, the fewer validators are required to be able to collude against a blockchain. And hence, a low GINI is good and the high GINI is bad for decentralization. I want to repeat this. High GINI coefficients, something close to 100%, is bad because that means a small set of validators, a small oligopoly, can just censor transactions. A low GINI coefficient, on the other hand, is good because that implies that you need a lot of validators to censor transactions, which is unlikely. I repeat, high GINI, bad, low GINI, good. Next. And here we see some GINI coefficients of income by country to just give you some context. Here, for example, the worst countries in terms of GINI have about 50%. That's somewhere in Africa, in Southern Africa especially. But if you see, for example, European countries, the GINI coefficient of income is about 30%, and US is somewhere around 40–45%. So these are relatively good low GINI numbers. Next page, please. But GINI coefficients of wealth by country is quite high. You see, for example, US is 80%, Turkey is a little lower. So wealth is more unequally distributed compared to income. Next page, please. And now we have the GINI coefficient of avalanche validators. These are the validator machines. And here you see that the GINI coefficient is very high. It's 90%. That's bad. It means that only a small set of validators combined can censor your transactions. Let me check the numbers. So you have here something like 1,800 validators, and only 27 of them together control 30% of the staked AVAX. So 27 validator machines combined can censor your transactions. Next page, please. Here we have the same graph, but this time the validators have been grouped by the reward address, because some people run more than one validator machine, which implies a different GINI coefficient. In this case, the GINI coefficient is a little less, 86.4%, but which is still very, very high. And in this case, we have 1,827 total validators by reward address, and 1,043 validators by reward address. And out of these, at most 22 validators combined can censor your transaction. So all your money is trusted essentially to 22 top validators. The richest 22 top validators control the network in Avalanche. Next page, please. And here I've looked at the top 20 validators, which taken together just barely make 30%, and the difference to 22 or 21 is because here together they have like 29.5%. So I just rounded this. And if you look at this graph, what you see is that almost all of them are on Amazon. It's a little bit not very readable, and or Hetzner. And it's really literally just a small group of 21 validators which control 30% of the staked AVAX, and hence have the right to censor, have the capacity to censor transactions. And that's a problem we want to solve. Next, please. Next page, please. And here you see, it's not very visible. Here you have a world map. And on the world map, on the left-hand side, you have US. In the center, you have Europe. And on the right-hand side, you have Asia. And you see those 20 validators are distributed on the planet across only 12 locations, most of them on Amazon servers. And you see this number just keeps getting smaller and smaller. And so if you can somehow influence these 20 validators across only 12 locations, then you can disrupt the network. And please note, these are upper thresholds. So in reality, it may be even less validators in less locations, in 12 locations. Next page, please. So we have seen proof of stake blockchains have a problem where staked AVAX or staked ETH, doesn't really matter, all of them have the same problem, have a distribution problem. Very few validators control a lot of wealth, and because this wealth is distributed among the validators, the Gini coefficient of wealth and income is the same. And in both cases, it's about 90%, because the income on the staked AVAX or ETH is actually not taxed inside the blockchain. It's just distributed proportionally. But in reality, as we have seen before, real countries, they tax the rich people. Most have some sort of progressive taxation where richer people pay a richer percentage of their income, which leads to have a smaller Gini coefficient for the income. But in blockchains, proof of stake blockchains, that's not the case. That's not the case. Rich people get the same proportional amount and they can just restake, and poor validators, they get the same proportional amount, but those poor validators have a relatively higher cost base. If every validator costs the same, then the poor validators pay more, and which leads to higher and higher and higher concentration, which is what we try to solve with XPower. XPower is a proof of work token, XPOV token, which actually runs on Avalanche, and which allows you to mint tokens using proof of work. We have seen, like in Bitcoin, proof of work, electricity is distributed a lot better compared to wealth, you know. And because of this, being able to mine and then mint your XPOV tokens on a blockchain really gives everybody an equal amount of chance to access those tokens. Next page, please. All right. What can you do with those XPower with those XPower tokens? With your capital, you can deposit this XPower capital, these tokens, into NFTs, which have then various levels of interest rates, which are distributed. Next page, please. And these staked NFTs distribute APOV tokens, and these APOV tokens can be claimed, and then you get them onto your address. So simple. You spend energy. You deposit them into XPOV tokens. You then get these NFTs, and these NFTs then start giving you APOV rewards. Next page, please. And the supply rate of APOV tokens is limited to about 1 token per minute, which corresponds to about 500,000 tokens per year. Next. And this is the overview of the XPower project. On the top left, you mine them, and then you get this some magic number, which is called nonce. And using these nonce, you can mint the XPower tokens on the top right. And once you have minted those XPower tokens, you can deposit them into NFTs. And once you stake those NFTs, you can start claiming regularly APOV tokens. And later on, we will implement lending and borrowing. And with these APOV tokens, we plan later on to start our own Avalanche subnet, which we hope will have a much better protection thanks to this mechanism we have set up with proof of work combined with staking. In such a case, everybody has equal chance to create XPOV tokens for them, and then to start claiming APOV tokens, which will become then our fee token on our subnet. Next page, please. I think I'm already done. All right. Thank you very much. Mine XPOV at xpowermine.com. We've got NFTs too with APOV rewards. Have a nice day.